All right, 2.4b, complex numbers. What does it mean to be complex? Real and imaginary. Okay, most of the time it's in the form of a plus bi. That's the standard form of a complex number. Now, these have special names. These are complex conjugates. All right. When you do the complex conjugate of one another, it's just the first and the last. All right. So if you have a plus bi, the conjugate is a minus bi. So in this first one we have is 1 plus I. What would be the conjugate of 1 plus I? 1 minus I. And so when we multiply those together, I do the first and the last. The first would be what? 1 times 1, which is 1. And then times the last together. So I'd end up with negative I squared. All right. And what do we replace I squared with? Negative 1. So then I'd replace that with negative 1, and I'd end up with 2. 1 plus 1 most of the time is 2. All right. This next one I have is 4 minus 3i. So what would be its complex conjugate? 4 plus 3i. All right. And so when we multiply by its complex conjugate, my first would end up being what? 16. My last would be negative 9i squared. And I'd replace I squared with what? Negative 1. So then I'd have negative 9 times negative 1, which is positive 9. 16 plus 9 is 25. Now, what you should notice about when we deal with these complex conjugates, is it a complex number anymore? No, it's just a what? It's just a real whole number. All right, it's just a real number, and that's the reason why we use those complex. I have 2 plus 3i over 4 minus 2i. And so I have a fraction going on, and I need to write this fraction, this quotient, in standard form. And standard form, again, is a plus bi. All right, so I have a plus bi basically over a plus bi. I don't want that. Okay, so guess what we're going to do? We're going to multiply by its what? Its conjugate. Now, which one? The bottom one. So I'm going to manipulate the bottom. So I'm going to multiply by 4 plus 2i. And so if I multiply on the bottom, I also need to multiply on top by 4 plus 2i. We're essentially multiplying by 1. All right, we're just changing the way it looks. Now, up top, we're going to use a 4-letter F word. What are we going to do up top? We're going to FOIL it. So what's my first? 8. My outer? 4i. My inner? 12i. My last? Plus 6i squared. Over. Now, these are complex conjugates of one another, so I don't need to do my middle terms. So what's my first? 16 minus 4i squared. All right, I like to work with the bottom first. I don't know why. So I have 16 minus 4 times I squared. What's I squared again? Negative 1. So now I have a negative 4. Play with the negative 1, which is 4. 16 plus 4 is 20. And then up top, what do I replace I squared with again? Negative 1. So now I have 6 times negative 1, which is negative 6, plus 8, which is 2. And then how many i's do I have? 16i. All right. I am good with it being right here. Okay? Does everybody hear me? I am good if you get there. Okay? When you look up your answers on CalcChat, which I do encourage you to do, they're actually going to distribute dividing by 20. All right? Technically, that is what you should do. So if I distribute dividing by 20, 2 over 20 reduces to what? 1 over 10. And then 6 over 20 actually simplifies to 4 over 5i. So CalcChat's going to go that extra step. Okay? And technically, that is what you're supposed to do. However, I am good right here. Does everybody hear me there? All right? I really don't think it's that necessary. Okay? All right. Let's keep moving. So now we're going to do what's called the principal square root of a negative. What is I again? I is really what? Square root negative 1. All right? So if I have square root of negative 3 in this case, well, that's really like 3 times negative 1, true? And negative 1 and the square root is really I. Now, I don't like this notation. I'm only going to put my i's in front. So I'm going to put it as I square root 3 because I think this is really hard to do when you write because doesn't this look kind of like it might be underneath the square root bar? Yeah. So I'm always going to put them out front. All right, I think it's going to make your life a little easier. All right, so part A, I have square root negative 3 times square root negative 12. Well, what can come out to play? I. So this is really saying I square root 3 times I square root 12. So now when I multiply these together, I do I times I, which is I squared. And then I have square root of 3 times square root of 12, which we call square root 36. All right. And so I squared is actually negative 1. And then square root 36 is really 6. So I have negative 1 times 6, which is negative 6. All right. All right, let's look at part B. I have square root negative 4 minus square root of negative 27. Well, I have square roots of negatives again, so what's going to come out of them? I's. But now let's deal with this 48 thing. Who's perfect? What perfect factors do I have in square root of 48? And what I mean by perfect factors is 1 squared is 1, right? 2 squared is 4. 3 squared is 9. Who else is perfect? 16, 25, 36. You know what I'm saying? All right. So what perfect factors are there in 48? Okay, I hear you there. But let's go bigger. Let's go bigger than this. 16, right? 16 times 3 would work, right? So square root of 16 is what? 4. So I have a 4i coming out to play. And then who's left inside the house? Square root 3. All right. All right, so then what else can come out on this square root 27? Okay, so 9 is our perfect. So who goes come out? A 3. And so now I have a 3i square root what's left? 3. These are what's called like radicals and stuff. All right. So they act like variables. All right. So if I have 4i square root 3 minus 3i square root 3, how many I square root 3's do we have? Just 1. All right. So then I'm left with 1i square root 3. All right. All right, part C. I have negative 1 plus square root negative 3 quantity squared. So I'm just allowed to distribute that squared, right? Heck no. All right, I can't do that. What are we going to do with it? We're going to FOIL it. All right, I'm going to bring out my I. So now I have negative 1 plus I square root 3. And then I'd have negative 1 plus I square root 3 again. All right. So, what's my first? Just 1. And then my outer? Negative I square root 3. And what's my inner? Negative I square root 3. And what's my last? I squared and times 3. All right. Well, what do I want to replace I squared with?
Negative 1.
Negative 1. So now I have negative 1 times 3, which is? Negative 3 plus 1, we end up with? Negative 2. So now I have negative 2. And how many I square root 3's do I have? 2. So I have negative 2I square root 3. All right. So now I'm going to find complex solutions. All right. So in part A, I have x squared plus 4 equals 0. Before now, all of our solutions have been real numbers. All right, like 3, 0, right? Those are our solutions. I'm setting it equal to 0, so really I'm finding an x-intercept or a root or a 0, right? They're all called the same thing, right? When I substitute 0 in for y, remember? All right, so that's really what we're doing. How do I start solving A? Somebody said it. Subtract 4. All right, so I subtract 4. So now I'd end up with x squared is equal to negative 4. Well, how do I get to x now? I square root it. But when I square root something, what do I need to do? I need to have a plus or minus square root negative 4. All right, you're right. All right, so before, I would just say no real solutions, we'd move on, remember? All right, but now we actually have to find the complex solutions as well. Now, Joseph just said it. What is the square root of negative 4? It's 2y. So now I end up with x is equal to plus or minus 2i. All right, and technically we should put them in as ordered pairs of 2i comma 0 and negative 2i comma 0. All right. All right, part B. I have a quadratic. What do we like to do to quadratics? Factor them. Go for it. So how else can we solve a quadratic other than factoring? The quadratic formula. So here we go. Let's sing it, guys. All right. All right, here we go. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. All right. All right. So now we're going to use the quadratic formula on this. So I end up with x equals, what's my opposite of b? 2. And then we have plus or minus the square root of, what's my b squared? 4. Minus 4 times my a of, what's my a? 3. Times my c of 5. All over 2a. So 2 times 3, which is 6. Now we need to start simplifying this a little bit. So what's 4 times 3? 12. 12 times 5? 60. 4 minus 60 is negative 56. So now I end up with 2 plus or minus the square root of negative 56 all over 6. All right. Now, I have square root of negative 56. So an I can come out, true? But who's perfect in square root of 56? Who's perfect in 56? 4. 4 is perfect. So who gets to come out? 2. All right, 2 gets to come out. So I have a 2 and an I coming out, but who's left inside? 14, there we go. All right, all over 6. All right, so now I have 2 solutions going on. I have 2 plus 2i square root 14 over 6 comma 0, and I end up having 2 minus 2i square root 14 over 6 comma 0. All right. Now technically you should distribute what? Dividing by 6. All right. So really you'd have 1/3 plus 1/3 I square root 14, and then 1/3 minus 1/3 I square root 14. But I told you on the other part, I'm really cool with you staying right there. All right. I don't really need you to distribute dividing. All right. On this one, I need common denominators. All right. But I never like to subtract. What would I suggest you do? Distribute the negative. All right. So instead of adding the fractions or subtracting the fractions, let's add them. But I need common denominators. But what are these denominators? These are what of each other? These are conjugates. So that makes it real nice. All right. What does this fraction need? The 1 minus I. What does this fraction need? The 1 plus I. So now when I rewrite it, I'd have 2 times what? 1 minus I. And then I'd have plus a negative 3 times what? What does this fraction need? The 1 plus I. All right? And then it's over. What do we do with those denominators? We do what to them? We multiply them. We multiply them. So now we have 1 plus I. And then 1 minus I. All right. What are we going to do up top? What word? We're going to distribute. So what do we get up top? 2 minus 2i. And then we're going to distribute again. So then we end up with not 3, but negative 3 and then minus 3i. And then we have conjugates on the bottom, so we just need the what parts? The first and the last. So we just need the first and the last part. So my first is what? 1, and then my last is negative I squared. All right. What do I replace I squared with? Negative 1. So what do I get on the bottom now? I get 2, and that's the whole reason why we do it. All right, we got that whole number of 2 on the bottom. And so what does my top simplify to? I end up with negative 1 and then minus 5i. And again, I am cool with it right there. All right, I am good with it right there. When you look on CalcChat, you're gonna see them distribute to that version, but I am cool with it right there. Okay? All right.